Hi again. So now that we've reviewed what a sampling distribution is, kind of the foundation for all of our inference, let's go through the steps for a hypothesis test for a proportion, okay? So the theoretical hypothesis test for a proportion uses the normal model, and we saw in the last video that model uses the normal distribution. And then the steps are similar to using a randomization distribution. That's what we did with our simulation. Okay, what's different is we're going to calculate a test statistic. So we did not do that with a simulation. And then we're going to find our p-value. Instead of this using a simulation, we're going to find it with the normal curve, okay? The normal model. So let's go through the steps here. Here's the steps, and it's called a z-test of a proportion. That's kind of the shorthand for this test. Okay, so our steps are to write out the hypotheses, which we did the same as with the simulation. What's new is we have to check the conditions, because when we're using a model, we have to make sure that we have that normal shape, okay? So we're going to use the central limit theorem, those conditions, and just to refresh, those four are independence, randomization, large population, and success failure condition. We're going to use P0 when we're checking the success failure condition. Because we're assuming the null is true, we're going to use, and the P0 is the value of the null, we're going to use that because we're assuming the null is true. So I'm going to write out that's the null value. Okay. Let me just underline this first one as well. Then the next thing we're going to do is we're going to write out the observed statistic, which is p hat. And then we're going to calculate our test statistic. And here's our formula for our test statistic. It is a z-score, so that's why it uses the letter z. It's the z-score of p hat. So I'll write that out. Okay, so if you remember about z-scores, and we'll review as we go, one standard deviation away, or in this case, one standard error away, is considered average. When you get out to 2, that's getting more unusual, and 3 is rare. So just knowing this test statistic is at 1.2 or 3.5 gives you a sense already of how usual or unusual our sample or observed statistic is. Okay, so this is a z-score. It's the value minus the mean divided by the standard error. So that square root is the standard error. You might recognize that from our last video, but it does have the zeros on it to use the null value. Okay. Okay, once we get our z test statistic, we're going to use the normal calculator, and this is our model. Z-scores follow a normal model, so remember z is distributed as normal with a mean of 0 and a standard error or standard deviation of 1. Okay, so we'll use that to find our p-value. The next step will be to compare the p-value with the significance level. So A, B, D is our same, sorry, just A, and then once you get your p-value, then it's the same as we did with the simulation. The middle part is the different part. So once we get our p-value, we'll compare that with our significance level alpha, and then we'll determine whether the result is statistically significant or not. Then we'll state our conclusion. And in context, we always want to put the context in our conclusion. Communication is another big theme I have in this course because, well, there's a video I'll show you, I'll put in that tells you why. It has to do with my statistical experience at Saturn. Communication is so important because we can't expect anyone to understand statistics. We need to spell it out. Okay, so it might feel obvious, but we need to spell it out, write it out in context. We're going to include the p-value, and then whether we reject or fail to reject the null hypothesis. Okay, so those are the steps. We're going to go through the steps, but first let's write out well, actually, we are going through the steps, but we already wrote out, let me get the page. We've actually already started this problem. So remember on the first page, we read this health insurance problem, okay? And so we've actually already started the steps. We wrote out our null hypotheses. We also wrote out our observed statistic p hat, okay? So we've got that. Then we need to check the conditions. So I will do that next. And if it helps you to write the letters, you can do that. I'll do that in some examples. You're always welcome to do that. Okay, so next we need to write out the conditions for this health insurance test. Okay, so, and the conditions are on the other page right here to have a little more detail right here. Okay, so I'm going to follow those steps. Okay, so independence. Okay, so we always want to write out what we need. We want to consider, remember, we're always getting data at the end of a test, but we want to consider if we were gathering this data at the very beginning, what do we need to consider in order to get, in order to have independence for our sample, okay? So yes, we're going to take a random sample, that's the second one, but we want to think about how would we get that random sample and what are the different factors we need to consider, okay? So first I'm going to write out what it means, what we need for independence. So the PCC students in our sample must be independent in terms of, I always want to write the variable, okay? In terms of, in this case, we're measuring or recording whether they have health insurance or not, okay? So in terms of having health insurance. Okay, so first we want to write that out. Then we want to consider what are the factors we would want to consider if we were to get this sample ourselves, right? We wouldn't want to just have students in only one class or only one major, right? Or only one modality of class, like online versus in person. Okay, so I want to write down a bunch of these different factors we need to consider. So consider I'll say consider age. Like age might really be a factor in health insurance, whether someone's covered by their parents still or not. So I'm going to say age, gender. We always want to consider race and ethnicity. Maybe whether someone's employed or not. We could look at credit students versus non-credit. Maybe international students, and you might think of more or different ones. That's totally fine. I'm just looking for a few things that you would look at to consider that might affect that variable, okay? International students. Okay, you could always list more as well. I'll say etc. Okay, so essentially we want to get, in this sample, we want to get a representative sample and an unbiased sample, right? Okay, so then the next one is randomization. Considering all these factors, we want to get a random sample. We need a random okay, and often this will be told to us in the problem, but remember, we're writing out what we need because we would be doing this at the beginning of the process normally, not at the end of the process like we're doing in a statistics class. Okay, next one is large population. Okay, so this is when our population needs to be at least 10 times the sample size. So the population, so we also need to identify our population here. Even though we're comparing this PCC students with the state of Oregon, our population here is PCC students. So the population, that's where we're drawing our sample from, of PCC students must be at least 10 times, and our sample size is 300. I'll find that paper. I have too many papers here. Random sample of 300. Okay. So must be, and I love 10 because we can just add the 0 at the end. So it must be at least 3,000. Okay, I do believe that is true. Even if it's not, we're not sure in a certain question, we're gonna just write it out and keep going anyway. Okay, next one is success, failure, success, failure. Okay, so this is when we test n times p0 and n times q0 greater than or equal to 10. So we need to have at least 10 successes and failures. And we use p0. So I'm going to say n times p0. Our n is the 300. And our p0 is our null value of 0.96. Okay, so this is what we would expect. Remember, we're assuming the null is true, so we would expect that it matches that 96% of PCC students also have health insurance. So 0.96, we need to know if this combination of n and p is big enough to give us a normal model, okay, to have that symmetric normal shape. Okay, so 300 times 0.96 is 288. That is definitely greater than or equal to 10. One of these will be bigger and one of these will be smaller. So let's try n times q0. So this will be 300 times 1 minus 0.96. So if that's 96%, this will be 4%. And you could do that in your head, or you can just write out 1 minus 0.96, however you decide. So 300 parentheses 1 minus 0.96. Sometimes they'll have 3 or 4 digits and the subtraction is not as easy to do in one's head. This is 12, which is just barely, but it is greater than or equal to 10. And these two will always add up because these add up to 100%. These will add up to 300. So we also could have said, oh, well, if that's 288, that's successes, people we would expect to have health insurance, and failures would be who do not. The word success and failure is just a general term in statistics. I don't love the word failure, but it means, success means the thing we're counting or looking for, and failure is the thing, not the thing we're counting or looking for. Okay, so in this case, failure is not having health insurance, but it's not a failure in life, okay? Okay, so there are our conditions. our conditions. Okay, great. Let's just finish this page and then we'll do a new video for the next page. So we're still in our process. We just did B, which is checking the conditions using the null value. And then C is writing our observed statistic, which we actually did, but I'll repeat it here. And then calculating our test statistic, okay? So remember our p hat was the 284, let me move this up, 284 out of 300, which is 0.9467. And then we are going to do our test statistic, which is the z-score, okay? And I also have a spot here to review. What is a z-score and what does it represent? Okay, so we're going to use our formula, which is up higher on this page. So I'm just going to rewrite the formula. P hat minus P0 over the square root of P0 Q0 over N. Okay, so now I'm going to plug this in. So our P hat is 0.9467 minus our P0, that's our null value of 96, right? We got our one sample. We want to know how far is that from the null. And then we want to know how many standard errors is that. So we're going to divide by the standard error. So our P0 is 0.96, Q0 1 minus 0.96, all over N, which is 300. Okay, and then equals or approximately equals. Let's calculate that. So I'm going to see if I can get this all on here without covering it up. 0.9467 minus 0.96. Now, because this is a subtraction before a division, we need parentheses or I need to hit enter. So I'm going to hit enter first, and that's the difference. But I'm also going to, whoops, I moved my paper. I'm also going to write in parentheses right here, just to remind you. And also we'll show you this on Desmos probably in the next video, because that's a really great calculator as well, and I want to show you both ways. Okay, so we've got our subtraction. Now I can divide by the square root. So I have to do second square root on my calculator. 0.96 parentheses 1 minus 0.96 close parentheses divided by 300. But see how everything is still in the square root? So even though I've closed my parentheses, I'm still in the square root. So make sure you're still in the square root in your calculator. And this is negative 1.1756. I'm rounding everything to 4 digits, okay? And then that 4th digit, we have to look at the 5th digit, 1755. The next one is a 6, and so that bumps this 5 up to a 6. So negative, yes, okay, great. And this is, what we're measuring here is standard errors. So this observed statistic that we got, the result from our sample, is, and it's negative, so that means it's below the mean, which makes sense because we're doing a left tail test. We're interested if it's lower, right? So it is lower. We just don't know if it's significantly lower or not. It's a little over 1 standard error away from the mean, okay? Okay, so I will continue this on the next page and the next video, and I will see you then.